Hello, Assalamu alaikum everyone. Welcome to Econometric and Research Gateway. Now, in this video, we are going to talk about uh, the unit root test, which is basically our fourth step or the fourth video related to the debate for the MMQR full tutorial with the latest publication example from the energy economics. So, in this fourth video, let me show you. So this is actually the output as generated in the sample article which we are following actually. Here comes the table 4 covering the unit root testing or checking the stationarity property of the data. Here comes our key variables, and here comes the authors have tested the unit root or stationarity properties of the data at level, and here comes at first difference as well. So without losing time, we need to move on towards the data. Okay, here comes the data. As I told you in the previous lecture of video 3, we have tested the slope heterogeneity analysis, and it is clear that there exists the heterogeneity in the slope coefficients for both of the models. This was actually for model 1 and this was for model 2. Now we are moving towards testing for the unit root, for which the command is very simple. The command is xtcips, our first variable. Now our first variable is carbon emission, which is CO2. Space, comma, max lags into 1. Normally we set max lags at 1 and BG lags into 1. So this is actually the command for checking whether the data is stationarity at level or not. And we need to press enter. Now we can find that here comes the test statistics for the CIPS unit root test, which is basically known as Pissarra and panel unit root test with the help of cross sectional first difference, mean included, etc. Okay. Now we need to compare this value, this statistics value, with the given critical values at 1% or at 5%. For example, we can find that this value is minus 1.478 and the critical value is minus 2.3. Now we need to check whether this value is greater than this critical value at 1% or at 5%. Now we can find that this value y minus 1.478 is less than this critical value at 1% and even at 5% and even at 10%, means that our data is not covering the stationarity property at level. So what we have to do, we have to take the first difference of this, you can say, the carbon emission. So the process is quite simple. We need to type dCO2. The already dCO2 variable is already generated in your list. You simply can click on this one, or you simply need to just click this command and move it here, and simply need to type dCO2 and need to press enter. Now you can find that the CIPS unit root test is showing the test statistics of minus 5.509, which is highly significant at 1%, because this value is minus 2.3, this value is minus 5.509. So this value should be highly significant at 1%. So it is significant at 1%. We can say that the data for the carbon emission is showing the stationarity property at first difference, and the same has been reported in our table 4. This is actually for the table 4, which is unit root test. Here comes our first variable. Now you can check that the values for the carbon emission at level is minus 1.478. The same we have generated. Let me cross verify it. Yes, this one, minus 1.478, minus 1.478. This value is not significant at 1%, but it is actually significant at first difference. This one. So this value is significant at 1%. So we can say that the data for the carbon emission has become stationarity at first difference, but not at level. Now we need to repeat the same process for the rest of the variables. So the command is very simple. Just click over this command. This one, we need to type the name of our second variable, which is basically GF Green Financing. And you need to simply press the enter. Now you can find the CIPS value is minus 3.282, and it is significant at 1%. And the same you can find it over here. So this one is actually significant at 1%. No need to go to the first difference. Okay. Now we have to move on towards our third variable, and our third variable is import IN. Enter. Now the value is minus 2.254, and this one is minus 2.3. Now this value is also significant at 1%. Now this value is also significant at, you can say, the 5%, sorry, not 1%. So you can say that this the data for the import is also highly significant. So it is showing the stationarity property at level. Now we need to move on towards the next variable, which is GDP. You need to enter GDP. Just enter. Here comes the GDP. Now the test statistics for the GDP in terms of CIPS is minus 1.621, but this value is minus 2.3, so it is not significant. Now what we have to do, we have to take the first difference, DGDP, and enter. Now this value is minus 3.59. Okay, now this value is minus 3.595, which is highly significant at 1%, and the same has been reported in sample table 4. Now we can see that the data for the GDP has become stationary at first difference. Now we have to move on towards the EPS. What we have to do, simply we need to remove this one, and we will type EPS, environmental policy stringency, just to check whether it is stationarity at level or at first difference. Need to press enter. Now this value is minus 3.579, and it is also significant at 1%. The same has been reported over here, this one. Now the last variable is green innovation. Okay, so we need to remove, we need to remove EPS, and we will type GI. Now the value is minus 3.19190, which is also significant at 1%. Now the same has been reported in sample table 4. So guys, this is all about how we can check the stationarity properties of the data while using the Stata 17 through CIPS unit root test. Thank you.